Okay, I welcome you all. In today's session, we are going to learn the Bresenham's line drawing algorithm. Okay, in previous session, we have learned the DD line drawing algorithm, how it works, and today we are going to learn Bresenham's line drawing algorithm. Okay, so the point we are going to discuss is today is Bresenham's line drawing algorithm. Now, before we move to the Bresenham's line drawing algorithm, okay, we understand which are the drawbacks of DD line drawing algorithm. Okay, or where exactly the detailed line drawing algorithm fails. Okay, so what we are considering, as we have seen the detailed line drawing algorithm, okay, the values of delta x and delta y as well as whatever we are calculating, all it uses is floating point values or floating point arithmetic. Okay, so this floating point arithmetic, okay, in detailed line drawing algorithm, it is going to take a more computation time. Okay, it will take more time for calculating the floating arithmetic. And as this floating point arithmetic, it is also difficult to implement into the hardware, or hardware implementation of the detailed line drawing algorithm is difficult, because if I consider only the integer arithmetic, okay, so the arithmetic calculations are integer, the algorithm will be, my algorithm will be very fast, okay, and it will easy to implement into the hardware. Okay, as the DDA line drawing algorithm is having these two drawbacks, okay, for that we are considering both are interrelated with each other. Okay, floating point arithmetic is required, therefore the computation time is higher, as well as it is difficult to implement in the hardware part. Okay, now due to these two things, okay, and to overcome this drawbacks, okay, what we are going to use is we are going to use the Bresenham's line drawing algorithm. Okay, so you can find nowadays that maximum package or all the computer graphics package uses the Bresenham's line drawing algorithm to draw their line. Okay, now the algorithm seeks to select or try to find out the optimum raster location, or trying to find out the optimum pixel that represent a straight line. Okay, so though it uses the rasterization, and it is trying to find out the optimal or optimum raster location or the pixel that represent the straight line. Let us consider what is the basic idea of this algorithm. What is the basic idea behind the Bresenham's line drawing algorithm? Okay, so if you observe all the different lines that we have drawn, okay, what is our observation is the algorithm always increment, okay, always increment by 1 unit in either x or y direction. Okay, suppose assume that I'm just drawing the line here. Okay, suppose this is my line. Okay, not it is exact straight line, but this is my line. This line is what we know. We know that this particular line is the horizontal line. Okay, and x is incremented. So what will happen in this particular case is the x value, okay, in this particular case the x is always incremented by 1. X is always incremented by 1, and the y value, if I consider, it will not change, it will be 0. Okay, so depending upon the slope of the line, for this slope of the line, the increment in another variable either 0 or 1, whether I have to increment another variable with value 0 or 1, is determined by examining, by finding out the distance between the actual line and the nearest grid location. And here the Bresenham's algorithm has suggested the new term which is called as the error term. Okay, so that distance is called as the error. Okay, suppose I consider my line is vertical. Okay, suppose this is my line, where my line is a vertical line. I'm having a vertical line. Okay, vertical line means what will happen in this case? The y value, okay, is always incremented by 1, and the x value will be 0. Okay, so x is 0 and y is always incremented. Okay, if I draw a diagonal line, suppose this is my line. Okay, I'm drawing a diagonal line. What will happen in diagonal line? The x is also incremented and y is also incremented. So both will be incremented by 1. Okay, So this is what the basic idea behind the Bresenham's line drawing algorithm. I repeat it again. What is the idea is depending upon depending upon the slope of the line, the one variable, maybe either x or maybe either y, one variable is always incremented by 1, and whether to increment another variable. Suppose I assume that x is always incremented by 1. Okay, now the y value, whether to increment y or not, whether y will be either incremented by 0 or 1, okay, it depends upon the term which is called as the error term. Okay, it depends upon the distance between actual line and the nearest grid location, and this is what happens into the Bresenham line drawing algorithm. Okay, so to understand these things again in detail, okay, we move to the next slide. Now in this particular diagram, I want everyone to focus on the diagram that we have drawn, and then we will read this whatever I have written. Okay, whatever the points as written. Okay, now assume that, so whatever the pixel I am having, so I am having this pixel as 0 0. So this is my 0 0 pixel. Okay, getting it? This is my 0 0 pixel. Okay, now what is my next pixel? My next pixel will be either 1 comma 0, it may be 1 comma 1, it may be 0 comma 1. Okay, so either these 3 pixels are there. Okay, suppose in this particular case I assume that the x always increment by 1. Okay, so what I'm considering here, yeah, x is always incremented by 1. Okay, then this x value, this is my x value. Okay, this 0 is my x value. Okay, so I'm just considering it as this is the x value that I'm having. X value is always incremented by 1, so x will becomes 1. Okay, x is always incremented by 1, x is become 1. This is also indicate that x is 1. Okay, but now the value of y, okay, this is what my value, okay, that I consider this is my y value. Okay, now the y value may, if it is not incremented, it will be 0. If it is incremented, it will be 1. Okay, now this y value, now it depends upon, now suppose just I am just considering that this is my 0 0, this is 1 0, this is 1 1, this is 0 1. Okay, so x is always incremented, so my x value will be 1. But now y value, whether to increment it or not, or whether the y value will be 0 or whether it is 1, it now depends upon the error term. Okay, so I am considering that it is based upon the error term. Now assume that this is my line. Okay, this is my line. Okay, and this is nothing but this is my 0.5 value. This is the centrum because this is 0. See, I am talking about y line. Okay, this is my y line. This value will vary from 0 to 1. Okay, and this value I consider the center of this will be 0.5. Okay, so just I consider this value is 0.5. Okay, so this 0.5 value, so now I have to calculate the error term. Okay, so we are calculating the error term here, and now the error term in this case is, now this indicate my error term. Look at the diagram. I call this is my e, this is nothing but e, this is the error term. Okay, now what the rasterization says, I have to find out the nearest grid location. Okay, so if my, just look at this, if my slope of the line, okay, if my slope of the line is less than this 0.5, less than this center, okay, so my actual line is passes and the slope of the line is less than this, which pixel is activated? Obviously I am going to activate 1 by 0 pixel. Okay, whereas if this error term value is greater than 0.5, means it is above this, okay, what will happen? Which is the correct pixel? Then this will be the correct pixel which we have to activate. Okay, now the same thing is written here. I want everyone to look at this. If the slope of the required line through 0 0, if the slope, what I'm saying, the slope of the line, if the slope of the line is greater than 0.5, okay, if it is greater than 0.5 means what will happen? My actual pixel is lies somewhere here. Okay, it is somewhere pointing at this side. Okay, greater than 0.5. This is what I'm saying, greater than 0.5. Okay, then it intercepts the line x is equal to 1 is closer to the line y is equal to 1. Okay, then line y equal to 0. Therefore, raster point 1 comma 1 is better represent the path of the line than that of the 1.0. Okay, 1 comma 0. Okay, so if the what I'm saying is if the slope of the required line, if it is greater than 0.5, this is the correct pixel. Okay, if the slope of the line is less than 0.5, which pixel is correct? This is the correct pixel that I have to draw. Okay, so whether to select, okay, see what is my initial pixel? My initial pixel is 1 0 comma 0. Okay, this is my original pixel 0 0. X is always incremented by 1. I have assumed that x is having the maximum displacement, so x is always 1. 0 plus 1 1, x value is 1 here, it is also 1. Now I have to find out whether what should be the value of y. Okay, now this y value depends upon the error term. Okay, that's why I have shown it here. This is what my error term, it depends upon error term. And what is the condition? If error term is less than 0.5, the y is not incremented. Okay, y value will be 0. And if the error term is greater than 0.5, the y value is incremented and it will be 1. Okay, so the same thing that we have, that is what the idea behind the calculation of the error term. Okay, so the same error term definition is written here. I want everyone to read the error term. Error term records the distance measured perpendicular to the axis of greatest moment. So that is what I have shown it here, perpendicular to this particular value. Axis of greatest moment is x. X is always incremented, so x is my axis of greatest moment. Okay, between the exact path of the line and the actual dots generated. Okay, so this is what the error term is. Again I repeat, error term records the distance measured perpendicular to the axis of greatest moment between the exact path of the line and the actual dot which is generated. Okay, but now here as I am saying, my Bresenham algorithm should use integer value, so the algorithm needs only the sign of the error term. Okay, we have to just check whether my error term is positive. Okay, I have to just check the sign of it. I just check whether my error term is positive or whether it is negative. Okay, so I'm just taking the sign of the error term, whether it is positive or whether it is negative. So I just required the sign of my error term. Okay, now if I'm saying it is positive or negative, so what will I do? So I initialize my error term to 0.5, minus 0.5 rather. Okay, I initialize this to minus 0.5. Okay, what will happen due to minus 0.5? It is initialized. If my value is less than minus my 0.5, it will be 0. Okay, and if it is greater than 0.5, it will becomes 1. So that's why we initialize the, here also it is written, we are going to initialize the error term to minus 1 by 2. 1 by 2 means minus 0.5. And the value of error, how it is calculated. Okay, how to calculate the next error. So error is equal to error plus dy by dx. Okay, so we are calculating delta y by delta x dy by dx, that is the slope of the line. So error is equal to, that is what I have written, error is equal to error plus dy by dx. Okay, so this is what completely shows what is mean by the error term, and depending upon the error term we have to select the another value, whether to increment that value or not. Okay, so move to the next slide so that we can go through the algorithm. Now here we are considering, okay, now I want everyone to look at this. See, I have written the word here general Bresenham's algorithm. In previous case I have written only Bresenham, now I have written general. General means I want to draw the line in any quadrant. Okay, I want to draw the line in any quadrant. Okay, so if I considered, okay, so I just go through this. When absolute magnitude of the slope of the line is greater than 1, the y is incremented by 1. Okay, and the Bresenham's error criteria is used to determine whether to increment the x. Means if my slope of the line is greater than 1, okay, or I considered here the maximum displacement of the line. Okay, I consider the maximum displacement of the line is into the y direction, means y is higher, delta y is greater than delta x. Okay, y is always incremented in that case by 1, and the error term will decide whether to increment X or not. Okay, now here whether X or Y is incremented, okay, whether X or Y is incremented by +1 or -1, okay, it depends upon the quadrant. Okay, that's why I'm just showing you this diagram. Condition for general Bresenham's algorithm. General, here the word general indicate that I want to draw my line in all quadrants. Okay, so I consider this is my first quadrant. Okay, everyone knows the different quadrant that we are having. So this is what my first quadrant. Okay, quadrant number 1. In quadrant 1, if you just look at this quadrant 1, you can find that X is also incremented by 1 and Y is also incremented by 1. Okay, that is what we have written. And now this particular thing, now here, this one, okay, this is my diagonal side. Okay, or you can consider this as my diagonal value. Okay, in my diagonal value, you can find that if my line is somewhere here at this part, X is always incremented, correct? X is always incremented, and Y depends upon error term. Okay, if I'm drawing the line somewhere here, okay, at this side, somewhere here at this side, what will happen? Y is always incremented by 1 and X, whether to increment X or not, it depends upon the error term. Okay, now if I look at this quadrant number 2, okay, so I'm just moving to, this is my quadrant number 2, second quadrant. Okay, in my second quadrant, what will happen? The X value is X is equal to X minus 1. Okay, and Y is always incremented by 1. So increment Y by 1, but we have to increment X by -1. Okay, because I am moving Y into the negative direction. Sorry, I am moving X into the negative direction. So X is equal to X minus 1 in this particular quadrant, and Y is always incremented. Okay, now if I look at the third quadrant, okay, this is my 1, 2 and 3. This is my third quadrant. Okay, this area is my third quadrant. Okay, in the third quadrant you can find the value of Y is also decremented and the value of X is also decremented. Okay, so X is equal to X minus 1, Y is equal to Y minus 1. Okay, this is clear. Now if I see again, if I divide this particular in this quadrant, okay, into the octant, or suppose this is my line. Okay, if I consider this part, okay, my line is in this particular area, this area, my line is in this area, what will happen? Y is always decremented or incremented by -1, means it is decremented by 1, and my X depends upon the error term. Okay, that we have to find out. Suppose my line lies in this particular area. Yeah, in this area, if it is there, what will happen? X is always decremented by 1 or incremented by -1. X is equal to X minus 1 always, and Y depends upon the error term. Okay, similarly we will go to the quadrant number 4. That's why we can say accordingly in which quadrant we are drawing the line. Okay, I'm drawing the line in which quadrant. According to the quadrant in which I'm drawing the line, I have to find out the values, whether to increment it. So that is what we have written, whether X or Y is incremented by +1 or -1, it depends upon the quadrant. In the fourth quadrant, what will happen? In fourth quadrant, X is incremented, X is positive, so X is equal to X plus 1, but the Y is in negative direction, so Y is equal to Y minus 1. Okay, so in generalized algorithm, we have to consider all these points or all these things. Whenever I'm writing generalized, means I want to draw the line in any quadrant. Okay, my starting point of the line may start from this quadrant, second quadrant, and my line may move from this to this. This may be my line. Okay, so or I am in the line only in third quadrant. So this is my line. All the values are minus minus. Okay, so that is what we have to consider in the general Bresenham's algorithm. Okay, this is my generalized Bresenham algorithm. Okay, so with this understanding of what is meant by error term and the related to the quadrant, okay, we are moving to the actual algorithm of generalized Bresenham's algorithm. Okay, now in this particular case, you can find that I'm having this is my, I'm just divided it into the two. Okay, so this is my flow chart. Okay, and this is my algorithm. Okay, so now here we are not considering it as in all quadrants. I'm just considering it as a very simple algorithm. Okay, so in my algorithm, Everyone knows what is x1 and y1. This is my starting point of the line, and x2, y2 are my end point of the line. Okay, so in initialize, what we are going to do, x is equal to x1, y is equal to y1. Okay, then we calculate the delta x is equal to x2 minus x1 and delta y is y2 minus y1. Okay, so the same thing is here in the flowchart. In the flowchart, I will start and I will perform all these initial calculations. Okay, x is equal to x1, y is equal to y1, delta x is equal to x2 minus x1, delta y is equal to y2 minus y1, and here the e term, error term is calculated, is equal to, what is the error term? I think we have just seen in the previous slide, is equal to dy by dx minus 0.5. Okay, because we have initialized it to minus 0.5. Okay, so e is equal to dy by dx minus 0.5. Okay, but actually, as we have said, the Bresenham's algorithm should avoid the floating point arithmetic. So initialize the e bar. We are considering e bar to compensate for the non-zero intercept, and we calculate e bar is equal to 2 into dy by dy minus dx to avoid the arithmetic or floating point arithmetic. Okay, so we are calculated, because what is required for us, we required only the sign of error term. Only the sign of this error term is needed, not the actual value. Okay, so when I begin into the main loop, the same thing in the flowchart. If I look at the flowchart, I value is equal to, initial value of I is equal to 1. Now in this case, I have considered my maximum displacement is delta x. Okay, so my maximum x is always incremented by 1 and y depends upon error term. Okay, I repeat again, what this algorithm considered, the x is always incremented by 1, that's why I'm having I is equal to 1 to delta x, and the value of y now depends upon the error term. Okay, so initially, obviously, my starting point is x and y, x1 and y1. I will set that pixel, I will activate that pixel if I is equal to less than delta x. If I is less than delta x, plot that particular pixel. Simultaneously, I am explaining the flowchart as well as the algorithm. Okay, so plot x comma y or set pixel x comma y. Okay, now after that, I have to find out what is the sign of error term. This condition is very important. Or I will convert it into the while loop. If e bar or whether error term is greater than 0. Okay, so if the value of error term in this particular case, see what I'm saying, I have to continue with this loop until the error term, okay, until the e bar is greater than 0. Okay, what we have to do, so now this y value depends upon the error term. Y value depends upon the error term. So if e is greater than 0, now in this case greater than 0 means we have learned if it is greater than 0.5 value, then y is incremented by 1, so y is equal to y plus 1, and the new error term is calculated as e bar is equal to e bar minus 2 into delta x. Okay, so here the same thing in the flowchart. If e is less than 0, okay, if the value of error term is less than 0, what we have to do, if no, it is not greater than less than 0 means it is greater than, or it is, we can say it is positive. Okay, error term is greater than 0 means if error term is positive, what we are going to do is y value is incremented by 1, y is equal to y plus 1 and is equal to e minus 1. The same thing is done with the help of these two instructions. Okay, and this process is continued in while loop. See, this is continued until the error term is greater than 0. Okay, so we are taking the sign of that error term. If it is greater than 0 means if it is positive, y is incremented. If it is negative, the y is not incremented. Okay, and after setting the pixel, this while loop is used for whether to increment y or not. Okay, now if error term is less than 0, yes, means error term is negative. Look at the flowchart. If error term is negative, yes. Okay, what we have to do, there is no need to go for this y value to increment or decrement. We just go for x. Okay, so because x is always incremented by 1, x is equal to x plus 1. Okay, x is equal to x plus 1, and the new error term is calculated is equal to e bar plus 2 into dy. Okay, and next time again this process will continue until we reaches to the delta x. Okay, so this is what our Bresenham's algorithm. But now this Bresenham's algorithm, whatever we have discussed, okay, this Bresenham's algorithm, whatever we discussed, it is just considered for one quadrant. Okay, we are not considered for all quadrant. Okay, we are not considering it for the all quadrants. I would want to draw the line in any quadrant. Okay, my starting point of the line may be, for example, my starting of the point maybe start from my x value as -100 and means x1 y1 -100 and -100, and my end point may be considered as +100 and +100. Okay, so for this, okay, we will move to the next. This is the general algorithm and this is the flowchart. Now we are going to move to the in detail of the Bresenham's line drawing algorithm, which is generalized, which I can draw in any quadrant. Okay, so it is very interesting now. Okay, see, now this is my general Bresenham's algorithm, because this general one indicates that I want to draw the line in any quadrant, not only into the x and y positive values, it may be any value. Okay, so that's why the name is written generalized integer Bresenham's algorithm. This word is very important for all quadrant. This for all quadrant makes this as a general algorithm. Okay, we are knowing initially the line endpoints are x1 and y1. x1 y1 is my starting point and x2 y2 is my end point, assume not equal. Okay, now here what is the advantage of Bresenham's algorithm is all variables are assumed integer. Okay, so keep this as, remember this, the what is the advantage of Bresenham's algorithm as compared to detailed line drawing algorithm is all the variables are integer. Okay, if it is integer, all variables are integer, the algorithm will be very fast, it will draw the line very fast and it is easy to implement in hardware. Okay, now we are using this sign function. In the sign function returns the value -1. Okay, it will return -1 or 0 or 1 as its argument is less than 0. See, less than 0, what it's written? If it is less than 0, it is going to return -1. Indicate that I have to decrement the value. Okay, if it is equal to 0, if it is equal to 0, there is no need to increment or decrement the value. If it is greater than 0, means I'm having the value positive, it indicate it is going to return me the 1, indicate that my value is incremented. Okay, so the sign function is used whether I'm going to increment the value by -1, whether I'm adding only 0, I'm not incrementing or decrementing, means +0 only, and whether I'm incrementing by +1. Okay, so that's why I'm having this function. Initial variables, just now we have seen in the algorithm and flowchart, x is equal to x1, y is equal to y1. We calculate delta x and delta y. Delta x is absolute x2 minus x1. Delta y is absolute y2 minus y1. Okay, and now we assign this s1 and s2. Okay, now what is the use of this s1 and s2? This s1 and s2, this s1 will decide whether, that is the sign bracket x2 minus x1, so it will decide whether I have to increment the x or decrement the x, or it is not at all increment or decrement, means +0. Okay, it is added with 0. Okay, or whether it is added with -1, whether it is added with 1. Okay, similarly we calculate for s2. s1 is for x2 x, s2 is for y. s2 is equal to sign y2 minus y1. Okay, now as we are working in all the quadrant, we are not repeating the same for loop number of times. Okay, we have to we are not repeating the same for loop number of times. So we are always assuming that the delta x is maximum. Okay, I again repeat this. This is what the key of the general algorithm. Delta x is always considered as the maximum. Delta x is max. Delta x is maximum. Okay, so now I always consider delta x is maximum, but interchange delta x and delta y depend on the slope of the line. But if the delta y is greater, if delta y is greater than delta x, okay, I'm going to interchange delta x and delta y. If I to interchange, because I'm always considering, assuming that the delta x is maximum. So because my for loop will be from 1 to delta x. Okay, for loop will start from I is equal to 1 to delta x. Delta x is maximum value. My delta x is always maximum. Now, if delta y is greater than delta x, okay, my assumption is wrong now. Delta y is greater. So what I'm going to do, I'm going to interchange the delta x and delta y, and I'll assign that interchange is equal to 1. Okay, so what is the interchange is equal to 1? This is very important to remember. If interchange equal to 1 indicate that my delta y is greater than delta x. Else interchange is equal to 0. What is interchange equal to 0? Indicate that delta x is greater. Interchange equal to 1 indicate that what is greater? Delta x. Sorry. Interchange is equal to 1 indicate delta y is greater, and interchange equal to 0 indicate that my delta x is greater. Okay, the value of delta x is considered as the greater value. Okay, so I'm assuming here this particular thing is used so that I can use my for loop, which varies from 1 to delta x. Okay, and that depending upon the whether I have interchange is equal to 1 means delta y is y greater. So what is this delta y is greater indicate? See what will happen in the Bresenhams algorithm. What is the basic idea of Bresenhams algorithm is, if interchange is equal to 1 and delta y is greater than delta x, y is always incremented. Okay, and x depends upon error term. Okay, whereas if the interchange is equal to 0, okay, so see what I'm saying, interchange is equal to 0 means delta x is greater than delta y, and if delta x is greater than delta y, x is always incremented by 1 and y depends upon my error term. Okay, this is what the logic behind the interchange variable to use. Okay, simple calculation or simple idea behind the Bresenhams algorithm is, if delta y is greater than delta x, if my delta y is greater, y is always incremented by 1 and x depends upon error term. Whereas if delta x is greater, okay, what will happen? X is always incremented or decremented by 1 and y depends upon error term. Okay, this is what the logic behind it. Okay, continue with the algorithm. We are going to continue our discussion with the algorithm. Okay, now this is what the algorithm aims. Okay, now what we have to do the next is, after knowing the interchange, initialize the error term for non-zero intercept. We calculate the error term. Error term is equal to E bar is equal to 2 into dy minus dx. In the main loop, see what I have done. That is what I am saying. I is equal to 1 to delta x. I am always using the for loop where I is equal to 1 to delta x. Delta x is always greater. If delta x is not greater, we have interchanged it already. Okay, set the first pixel, set pixel x comma y. Now after setting the first pixel, what I have to do, I have to check whether the error term is greater than 0, sign of the error term. Now if error term is greater than 0, okay, now I have to check if the interchange is equal to 1. Okay, so this is the same thing came here again. If interchange is equal to 1 means what is greater? Delta y is greater and x depends upon error term. Getting me? So x is equal to x plus s1. Else, what is this else indicate? This else indicate interchange is equal to 0. Okay, in else part, if interchange is equal to 0 means what is greater? What is greater is my delta x. If my delta x is greater, okay, see what I'm saying, delta x is greater, my x always incremented and y depends upon the error term. Okay, so that's why in else part y is equal to y plus s2, and then I calculated this error term again. This while loop is used to check the sign of my error term. Okay, if after this what I have to do, I have one value I have to increment always. Okay, again the same thing, interchange is equal to 1, y is always incremented by 1, else interchange is equal to 0 means x is always incremented by 1, so x is equal to x plus s1. Now this s1 and s2 will decide whether to increment by 1, whether to decrement it by 1, or whether it is plus 0 only, nothing is not incremented, not decremented. So that's why we have calculated sign term. Again the new value of error term is calculated and the for loop is continued. Okay, so in this way we are in a position to plot or draw, see, all the pixels on the path of the line with the help of the Bresenhams algorithm. Okay, everyone knows the main advantage of this particular algorithm. What is the main advantage is it uses all the integer variables. Okay, and the basic idea is, if I'm having, okay, I show it again, if it all depends upon whether my value of delta x is greater. Okay, if my delta x is greater or highest, what will happen? X is always incremented or decremented by 1, x is always incremented or decremented by 1, and y depends upon error term. Getting me? Whereas what is my greater value? My greater value is suppose delta y. Okay, if my delta y is greater, This algorithm indicate y is always incremented or decremented by 1 and x depends upon error term or sign of the error term rather. Okay, so this is what the complete algorithm that we are having as the Bresenham's algorithm. Okay, so before concluding this session, I want we just consider one example. Okay, so we consider one example for considering some values, how this will be executed. Okay, so this is the example, general Bresenham algorithm example. Now here I am considering in this example to illustrate this algorithm, consider my line is, what is my starting point, 0 0. Okay, my starting point is 0 0, means my x is, or rather I say x1 is 0 and y1 is 0, and what is my end point, -8 and -4. See, we have taken particularly the example where my line moves in the negative direction. -8 and -4 means obviously it is my third quadrant. Okay, the line was previously considered in the example using DD algorithm, so now we can consider the same over here and can check it. Okay, so what is the initial calculation? X is equal to 0, this is my starting point, x is equal to x1, y is equal to y1, y1 is also 0 0, x1 0, y1 0. Okay, what is my delta x? X2 minus x1, so it will be -8 minus 0, so I will get like delta x is equal to x, and because we have also used absolute function, okay, absolute x2 minus x1, so my delta x is 8, delta y is y. Now in this case, delta x is 8, delta y is 4, means which one is greater? So I say that in this particular case is delta x is greater. Okay, delta x is greater than delta y. Okay, so if delta x is greater than delta y, what will happen? The interchange value will be 0. Okay, interchange is 0. Interchange 1 indicates dy is greater. Okay, so here interchange value is 0. Calculate the value of s1 and s2. This s1 and s2 will decide whether I have to increment or decrement. Okay, so in this case what will happen, I am moving into the negative direction, okay, in the diagram. So here I will get the -1 and -1. Okay, so incrementing and calculate the e bar value. The e bar value is calculated incrementing through loop. I can find what is my first pixel is 0 0. Set the pixel, first value is 0 0, so this pixel is activated, pixel 0 0 is activated. Okay, after that, as per my calculation, as I complete through the loop, my e bar is 8. Correct, e bar is 8 means it is positive. If it is positive, what I am going to do, okay, if it is positive value, e bar is positive, there is no need to look at the y value, so x value is -1. Okay, and in this case also, okay, I have to go for my y value is in the incrementing through while loop, okay, as per our previous slide. So this value, when it will be 0, it is -1, so my next point will be -1 -1. It is going to calculate this next point. What is the new value of e? It is minus. Okay, if it is, remember, if the error term is negative, okay, error term is negative, y value will not change. Okay, if error term is positive, it will be changed. So what is my next value? My point is, so here y value is not changed, so my next point activated will be a -2 and 1. In this way it will be continue. Okay, so continue with the loop. You can find I will get the line which is going to pass from all these points. Okay, so my line will be passing through all these pixels or the points, and I will get, this is what my line. Okay, so this is what we have learned related to the Bresenham's algorithm. As compared to the detailed line drawing algorithm advantage, it is simple to understand, but it is having the problem is it is having floating point arithmetic. Okay, and it is difficult to implement in the hardware. So everywhere, nowadays it uses, all graphics package uses generalized Bresenham's line drawing algorithm. Okay, it is very fast, the line will be drawn very fast, and it will be find out the accurate point on the path of the line, because it has introduced the concept of the error term. Okay, and the calculation and the drawing of the line is very easy. Okay, why it is easy? If we know that one increment means if it delta x is higher, x is always incremented or decremented by 1, and whether to decrement or increment y depends upon the error term. Okay, in reverse case, if delta y is greater, y is always incremented and decremented by 1, and x depends upon the error term. If we apply this simple logic, it is possible for us to draw the Bresenham's line drawing. Okay, line drawn very easily. Okay, I hope you understood, okay, the basic idea behind the Bresenham's algorithm, okay, and the general algorithm. Why it is general? Because we have to draw the line in all quadrant. Okay, in any quadrant it is possible to draw the line. Okay, so that's why it is generalized Bresenham's line drawing algorithm. Okay, so in the next lecture or next part of the lecture, we will see that how I can write the C program to implement the Bresenham's line drawing algorithm. Okay, C program for Bresenham's line drawing algorithm, okay, and its implementation. Okay, thank you all.